In this problem, we have a 2015 AIME 1 problem 13. With all angles measured in degrees, the product from k equals to 1 to k equals to 45 of cosecant squared of 2k minus 1 degrees equals to m to the power of n, where m and n are integers greater than 1. Find m plus n. So this is a classic product of signs problem from AIME. And they look intimidating with all those cosecants and odd angles, but they collapse if you use the right symmetry and trigonometric identities. So how do we break this down step by step? Okay, first look at the problem. We have a product of cosecant squared terms with odd angles from 1 degrees to, they'll be the odd numbers from 1, 3, 5, then go all the way to 89. So we have a product of cosecant squared terms with the odd angles 1 to 89 degrees. First rule of trig product is that cosecant is just 1 over sine. And dealing with sines is much easier because we have much more identities for them. So we can rewrite the target expression p. So we'll have p equals to we know from the expression product k equals to 1 to 45 of cosecant squared 2k minus 1 degrees equals to 1 over the product k equals to 1, 45. Cosecant means sine squared 2k minus 1 degrees. So our real goal is to find the value of the denominator. Let's call the product of these signs x. So we'll have x equals to this portion, or you can expand it to get sine 1 degrees times sine of 3 degrees times all the way to sine of 89 degrees. And then, if you find x, our answer is going to be 1 over x squared. So just looking at odd angles 1, 3, 5, well, that's tough. Trigonometry loves symmetry, so we can look at the complete set of integers from 1 to 179. We can define these three products based on the angles in the range 0 degrees to 180 degrees. So basically, we want to simplify this product. Well, we know that the product of all the angles is called as product total. Well, the product of sine k degrees for all integers k from 1 to 179. And then we know that this will equal to the product of the evens times the product of the odds. The product of sine k degrees for all even integers 2 to 178, and odd is for all odd integers from 1 to 179. And obviously the total product is just the evens times the odds. Now we can look closely at the product of all the odds. It contains the angles 1, 3 to 79, 179. Remember that sine theta equals to 180 degrees minus theta. So we can say that this is the key property of sine we need to note. Sine theta equals to sine of 180 degrees minus theta. This means the second half of the terms are identical to the first half. So sine 179 degrees equals to 1 degrees. And the pattern goes on. So it'll look like sine 179 degrees equals to sine of 1 degrees, sine of 177 degrees equals to sine of 3 degrees, sine of 91 degrees would equal to sine of 89 degrees. So the product of all the odds is actually our target product x squared. So to simplify, this will become odd product equals to from 45, from k equals to 1 to 45 of sine 2k minus 1 degrees squared equals to x squared. This is great because if we find the odd products, we have the denominator we need. Now, let's look at the even product. This is where the magic happens because the angles are 2, 4, 6, 178. We can write a general term as sine 2k. Use a double angle identity. So you'll have sine of 2 theta we know equals to 2 sine theta cosine theta. So the even product becomes k equals to 1 to 89. Because 89 times 2 is going to become 178, which is the last even one we have, of sine k degrees, and then times the products from cosine k degrees. So in essence, times cosine k degrees, and then don't forget the 2 here. So then, you can factor out the 2's, and there are 89 terms, so we can pull out 2 to the power of 89. So this becomes 2 to the power of 89, product k equals to 1 to 89 of sine k degrees times product k equals to 1 to 89 cosine k degrees. Now look at that cosine product. We know that cosine 1 degrees equals to sine of 89 degrees, cosine 2 degrees equals to sine of 88 degrees, and so on. The product of cosines from 1 to 89 is exactly the same as the product of sines from 1 to 89. So we can simplify this and get 2 to the power of 89 product k equals to 1 to 89 sine k degrees squared. And now we can relate this to the product of all the total numbers. And we can split this into 1 to 89 sine 90 degrees and 91 to 179. We know that sine 90 degrees equals to 1, and we know that the terms 91 to 179 mirror the terms 1 to 89. So the total product is also the product of the first 89 sine squared. So it'll become 1 times product k equals to 1 to 89 sine k k degrees squared. And now do you see it? Compare the equations from steps 3 and step 4. We know that product even equals to 2 to the power of 89 times the product sine k degrees squared. And then the product of total is equal to 1 times the product sine k degrees squared. So this will imply a beautiful relationship. The product of the evens equals to 2 to the power of 89 times the product of the total. So, the final solve, we are in the endgame now. We can go back to our first equation, which states that product total equals to product even times product odd. And then we can substitute product even equals to 2 to the power of 89 times product total. So then we'll get that the product odd is just going to equal to 1 over 2 to the power of 89, which is 2 to the power of negative 89. And recall from step 2 that product odd is exactly the denominator of our original problem, because the problem asks for cosecant squared, which is 1 over sine squared. And to be precise, we found that x squared equals to product odd. So then we can have the original expression is going to equal to 2 to the power of 89. And the problem states m to the power of n. So this satisfies that condition. So then we'll have m plus n equals to 2 plus 89. This equals to 91. And 91 is going to be the answer to this problem.